coding shared screen is visible, right? Screen is visible to you. Oh, okay, so we'll do talking using Vina today. Okay, so let me so Autotalk Vina. So here is Autotalk Vina. So when you install Autotalk Vina, download and install. So for Windows, you have to download this file and then install it, right? So when you install it, it should be okay. Let me just grab the drive. So when you install this, if you kept the default path, it will be installed in the same place where you have installed the Autodoc 4. Okay, so it will be in the program files and then the scripts research institute and then Vina. So from here you have to copy this .exe file, okay, and then paste it in your working folder. Where's that? So here these are the two examples from Autodoc 4. So let's keep one more folder name Vina, right? Or we can keep this as example. Okay, this is my working folder for today's session, right? So vina.exe. Okay, so the same procedure we have to follow till the generation or conversion of the receptor.pdbqt and ligand.pdbqt. Okay, so we'll do with the single ligand first, and for multiple ligand we'll be using a software called Pyrex, and then if possible we'll run the script also, but I don't think we'll be able to run the script today. But anyway, uh, in the tomorrow session we'll be running the script as well as do some this missing residue and all those topic. Okay, so anyway, this preparation, protein preparation, ligand preparation, we have done like the same like the previous session. So if you go back to our here, so the same prepared structure, that is the processed receptor in PDBQT format. So you can use the same tool, that is Autodoc tool, to prepare the receptor. You can just copy this as, let's copy one more, that is your ligand file, right? Where is that ligand.pdbqt? So it is, this is example number 2, so it is not there. So here is the process and ligand also will be present right here. So let's copy this the co-crystallized ligand as well as the receptor file, process receptor file, right, and paste it here. So we have the process receptor, process ligand, and the vina.exe file, right? So once you have this, so in Autodoc 4 we have to go to this Autodoc tool to generate the grid maps, right? So in Vina you don't have to generate the grid maps, but you have to give the information about where you want to dock. Okay, so if it is targeted docking, you have to give the same information as we have provided in the grid box. Okay, so remember yesterday, or day before yesterday. So so this is the xyz coordinate that we have given for the uh, this, I mean the box center, right? Grid box center, and then dimension was 40 40 40, I guess. So if you open this, so we are not going to use Autodoc tool, but I just want to show you the same information if you have done. Autodoc, for Autodoc tools, for me it's, I think it's having a problem, so I need to uninstall and install again. Okay, so let's just skip this for now. So let me just tell you one more thing. If this happens to your system, okay, sometime it happens. So Autodoc tools, Autodoc 4, Autodoc Vina, they are not that stable. Okay, so we have to be very patient when you are using these tools. So the tools are very powerful, but you also get these free bugs, okay, because these are free tools. So you have to be very patient with them. So what you can do is you can go to setting, okay, and then you can go to the control panel, or otherwise you can directly go from here, control panel, right? And then you have to go to this uninstall program. Okay, so in this you won't be able to find the Autodoc tool in the uninstalled program. Okay, for Autodoc Vina it will be there, but for Autodoc tools, if you want to uninstall the Autodoc tool, it won't be here. Okay, so what you can do is you can go to the C drive, program files. You have to go to the path where it was installed. Okay, so let's just search here MGL tools, right? So it is one of the application of MGL tools. So inside MGL tools you have the Autodoc tools also, but you can just uninstall MGL tools if you want to reinstall the Autodoc tool. Okay, so you have to click here, uninstall, click yes, and it will uninstall. So if you search in the control panel for uninstallation, you won't be able to find Autodoc tools here. Okay, I mean the main program, that is the MGL tools here. So you have to go to the path where you have installed the Autodoc tool. There is this MGL, I mean the whole program is the MGL tool. So you have to uninstall the MGL tools. Okay, you can just delete this, no issue. And then you have to reinstall it. So let me just see if I have a downloaded program or not. MGL tools, yes. So if you face problems or error or bugs like this, you uninstall it and install it again. Okay, there is no option, we have to go for that. I think I need to restart my system also, but let's just try this. So after uninstalling the software, it's better to restart the system also, but it is working now, right? So whenever you faced a problem with Autodoc tools, then you go for that uh, uninstallation from the path where you have installed the program, and then reinstall it. Okay, so this is Python molecular viewer, okay, not Autodoc tool. But if you want to use Autodoc tool from inside of this Python molecular viewer, you just have to click this button, so it will show you all the option for Autodoc tool also. So let's go to this grid and see. This is the information. We are not going to use the data that we have provided here, but I'm just showing you that the information that we have given in the previous grid setup, the same thing we have to use if you are using the same target. Okay, so for our case, let's say we are targeting the same thing, acetylcholinesterase and the drug molecule donepezil. We are doing redocking of that using Autodoc Vina. So you can use the same process receptor as well as the process ligand. Okay, and you have to provide this grid information, that is how much was the dimension that you used, or you can just view the dimension. You can just enter the grid box center if it is for a different target. See if your grid box is able to cover the whole protein active site. Once you are satisfied, you can just copy this XYZ centers, and then you have to create a file called the grid or configuration file. Okay, something called this configuration file. Instead of generating the grid map and all those steps that we have done for generating the grid map in Autodoc 4, you just have to create a file named configuration file. Okay, inside this configuration file you can keep the data about your grid box or the enclosure where you want to do the docking. Let me just get the grid box, just a second. Okay, okay. Okay, configuration file. Share this configuration file, but thing is, this is just a txt file, but the format that they have given, you have to exactly follow the same format. Okay, if you give comma here or full stop, then it will create problem, it will throw error. Okay, so what this configuration file is telling you is that you have a receptor. Okay, if you are doing a single docking, or single in the sense if you are targeting a single molecule or the drug target molecule. If you have the process receptor, then you just can give inside the configuration file. Okay, you can just define the receptor in the configuration file. Then you have defined the x, y, z. What is this? This is the center of the grid box. So if you again go back to this, yeah, this grid box center, right? X, Y, Z centers. So you are defining here the same thing that we have done yesterday, minus 14, minus 43, 27, right? And this is the XYZ dimension, okay? That is this one. So how big you want to keep the grid box. Okay. So yesterday we kept 40, right? So let's keep the same thing. 40, 40, 40. So I'll give you share the same configuration file, but you know you can change the name here if you are doing different target, and you can change the coordinate also, but the format that they have given here you have to follow the same format. Okay, so let's save this. You have the configuration file, you have the receptor ligand. So if you go back to the workflow, this is for Vina. Okay, so if you see the workflow, then we have the configuration file, right? Information about the receptor we have in the grid or the configuration file. So ligand you can provide from, I mean, outside of the configuration file, right? Or you can, if you are docking one molecule, you can also provide inside the configuration file. Okay, but for now let's just provide this ligand information outside of the configuration file. Okay, then you have to just run this Autodoc Vina. So this is very simple. I mean, in the Autodoc 4 you have to again go for that that uh, search parameter you have to do. Then for the same macromolecule you have to select the ligands, select the ligand again, create an output, then generate the doc parameter file, right? And then do run the Autodoc 4 command. So many steps were there, but in Autodoc Vina you can just create this configuration file. You have the receptor, you have the ligand, and you have the .exe file of the Vina, and that's it. After this you can just run Autodoc Vina. So Autodoc Vina you have to run through command line. Okay, so for running in command line, first you have to open the command prompt. Okay, so go to this option and then type here cmd. So when you type cmd you have something called this command prompt, and you just type open. Okay, click open. So this is the window for command prompt. So our command prompt is now in the C, the part of our command prompt is in C drive users PC, right? So but my this working folder where my files are there which I want to run for molecular docking, it's in this path, right? So this is in D drive, but the command prompt is in C drive, so I need to change the drive. So if you are in this, if you are doing in desktop or something in the C drive, you don't have need to change. Okay, but for me it is in D drive, so I need to change the drive. Okay, or the partition. So you can just keep the drive name, I said D and then colon. Okay, and press enter. See, it was C drive before, now it is changed to D drive. Again I need this path, right? So the command prompt should be pointing to this particular path should be inside this folder. So let me just go back here to change the path of this uh, or to change to this particular working folder path, I have to type cd. Okay, that means change directory and give a space, and once you copy this path like this from your working folder and then come back to the command prompt, you just do a right click, it will paste the path and then press enter. So when you press enter, now your command prompt is in the same directory or the same folder, right? So Vina example. If you want to see these files in this command prompt, you can type dir. Okay, so it will list out all the files that are present in this directory or the folder. So this is configuration.txt, yes, and then ligand.pdbqt, process.pdbqt, right, vina.exe file. So everything is present here. So now I can start running my command for docking using Vina. So I just have to type Vina. Okay, you can do .exe also, and then there is something called minus minus. All right, let's do configuration first. Minus minus config. Okay, so this is you can say a flag. Okay, config. Okay, uh, so this is some kind of command for this Vina program. When you type minus minus config, now after this command the program is expecting the configuration file. So since you are inside this folder and the configuration file name is this one, right, config.txt, so you can just type config.txt. So this is the flag for configuration. So it is telling you that minus minus config means I need a configuration file after this. So I'm giving the program the configuration file. Okay, so in the configuration file, what you have defined in the configuration file, the XY Z center of the grid box, how big the grid box should be, the dimension, as well as the receptor. Okay, so name of the receptor also you have given, so you don't need to define the receptor outside of the configuration file, but you haven't defined the ligand, right? So for ligand you have this flag called minus 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 ligand. Okay, after this command you you are expecting, or the program is expecting the ligand name in pdbqt format. So ours is ligand.pdbqt, right? And then one more thing is after docking, if you go for that Autodock 4, the output file was doc, I mean the name for output file, then dlg, right? So the same thing here. So you can go for minus minus out. So when you say minus minus out, you are or the program is, this flex tells the program that I want the output file. Okay, that means that after after docking the ligand in the with your target active site, the conformer should be stored in this particular file. Okay, so when you say minus minus out, you are telling which the output file that you want to give all the conformation after docking. Okay, so let's give what doc something like out dot pdbqt. So Vina and Autodock 4, they accept only the pdbqt format, right? And one more thing is minus minus lock. So this minus minus lock will give you the the scores of the dot confirmations. Okay, so you can say the log dot txt something. Okay, so this is all. So after defining all the necessary input and the commands, you can just press enter. So let's see. Okay, let's see if there is any error or it's running or not. So it's taking and it's running. Okay, so docking is done. It's showing minus 12.2, right? The first dock confirmation, right? So if you want other parameters that you want to change, then you can do one thing. Mind vina dot exe minus h. Okay, here you can find out what are the commands that you have, and you can see what they can do. Okay, so number of modes you can define here. So maximum number of binding modes to generate. If you give minus minus num modes, and the argument which means you want to keep 10 here, 7 here, 5 here, and minus minus energy range means by default it is 9. So if you can change this number of modes, and energy value means the difference between the first the highest scoring and then the next one. Okay, so if the energy difference between three are almost the same thing, then they are just taking uh, those energy ranges. Okay, and then this minus minus config means the configuration file. Okay, these are help, advanced, and versions. All right, so let's see the output files. Yeah, this is the output file, and this is the log file where it will contain the scores, right? So minus 12 is the first conformer is having the score of minus 12. Okay, so let's see what is the RMSD value, so that we can see if the dog confirmation as compared to the experimental confirmation, how much RMSD value it is giving you, so that you can see if the docking that you have performed is acceptable or not, right? So here is the 7 conformers are present inside this file. Okay, if you open this, so you have 7 conformers in PDBQT format. Okay, so here we cannot, I mean, it's difficult to say what are those conformers, but anyway, let's convert this into mol2 format, right? So we have to again separate this out, right, into single files, mol1 doc1 like that, doc2, doc3 like that. So in the case of Autodoc 4, using Autodoc tools, we just click the write all option, and they separated out the conformers into individual files, right? So for this, what you can do is you can use this OpenBabel. Okay, so when you install OpenBabel, you can access it from command prompt also, the same OpenBabel, but the command for OpenBabel, you don't have to write OpenBabel like that. Okay, you can type OBabel. So OBabel, then I think, let me just see if it is working or not. Yeah, it's working. Okay, so when you type OBabel and some information like this you can see, then means that it is working. Okay, let me see the command just in a second. Okay, so O Babel, then the input file. So what I'm doing is I want to separate or split this PDBQT file which contain the conformers of the dock molecules, right? So I want to separate this out as well as convert this into mol2 format, right? So doc RMSD only accept the mol2 format. So I want to separate or split the molecule into individual files, the conformers, and change it into mol2 format. So the input file is this one, right? So doc pdbqt and then a space, right, and minus capital O. Okay, remember, capital O, and then uh, just give some name. So I will just give dot, okay, dot mol2. You can give any name, so I just give dot mol2, or you can give the same name also, just doesn't matter because the extension will be different. So mol2, right? And then to split or separate these molecules into individual files, you can type -m. Okay, so press enter. So it has converted 7 molecules, and the first one is doc out 1.mol2, right? So they have separated out into individual files, and this is the first one, that is doc out 1.mol2. So if you look at this table, you see the first conformer is having the highest binding affinity, right? So let's take this one and then see again. Let's convert this. So instead of going to the graphical user interface of OpenBabel, you can just use this command line also. Okay, so for this, if you have to convert, the same thing, type O Babel. O is for Open Babel, and then the input file, so ligin.pdbqt, and then minus then space, right, minus capital O, and then you say ligin dot mol2. So this is single file, so I don't need to do the splitting. So that's it. So you have to press enter. So one molecule got converted, and you can see the output here. Okay, the same thing like yesterday. Let's see what is the RMSD value. Choose this. Again, choose this one also. Okay, so Veena is giving you much better redocking, okay, confirmation. So for Autodoc 4, it was like 0.6. So it is giving you 0.275. That means almost, similar with the uh, the the experimental confirmation. The redocking of the molecule is giving you almost the similar confirmation as the experimental one. Guys, following? Yes? Are you guys following? Okay, configuration file step. Okay, okay. See, Milan, configuration file is nothing uh, but a way to represent the, if you are doing targeted docking, represent the grid box. Okay, so the information about the grid box you have to provide like this. So I'll be giving you this particular file. Okay, that this config.txt file, you have to follow this same format. Okay, if your target is different, if you are doing different target docking, or your docking is different, I mean that docking you are doing is for different target, then you can change the name of this target. Okay, and then of course if the target is different, then your active site will be different, so you have to change the XYZ coordinates. For this example, we have used acetylcholinesterase. So for us acetylcholinesterase, this is the XYZ coordinate, or the central point or the centroid of the ligand. So if you keep the centroid or the central point of the ligand as the grid box center, then you will be essentially covering the whole active site pocket. So if you want to change the size or the dimension of the grid box, you can change the size here, same as like this. Okay, so this is the dimension, that is the XYZ dimension of the grid box, and this is the grid box center. The same thing you are giving here. This is the dimension, this is the grid box center, and this is the dimension. Okay, so once you have this configuration information, then, and the receptor processed one, and the ligand, the processed ligand, then you can simply do docking. Okay, so you have to just run this command, right? vina.exe minus minus configuration or config file that you need. So you give the name of the configuration, and this flag is minus minus ligand. That this flag is expecting the ligand name with the pdbqt and the ligand that you want to dock, and minus minus out means the docked confirmation files. Okay, after docking, what is the file that you want to, the name of the file that you want to save, and minus minus log means the log file that you want to save, or the information containing the that binding affinity table. Okay, got it? Milan, are you able to follow? Yeah, thank you. So this is Autodoc Vina, and if you go to Mastro, so now the problem is, see, for single molecule it is easy, right? You can do like this. Even for 10 molecules, you can repeat 10 times here. You can change the name of the ligand. Okay, if you have ligand 1, ligand 0, ligand 1, 2, 3, up to 9, you can still run one by one. Perhaps it takes time, but it's manageable, right? But imagine if you want to do docking for 1000 molecules. Okay, you have 1000 molecules or small molecule or 1000 ligands that you want to dock to your target molecule, and you want to see how it binds. Okay, so you will have 1000 log files, right? Log.txt files. You will have docked out or docking output file dot pdbqt, right? And again you have to run this 1,000 times, so it will take time, it will take your effort, right? And it is very hard to manage. So in order to do this in easy way, you can use a software called Pyrex. But before that, let me just show you how okay, let me just change this part of this software to working folder. Okay, import this again and this dot, right? You can just change the color also. In the last session, I will show you how to do all this thing. Okay, don't worry about this now. So this is the original confirmation. That is your green, your experimental structure, and this is the redocking one. Okay, so it's almost like somewhere here it's some kind of changes flip here, and that's it. It's, Vina is giving almost perfect confirmation as the experimental one. So Bina is better in this case. Our acetylcholinesterase, right? It's giving a better docking results. Anyway, so let's go to IDEX. Okay, so let me just show you how. Where is the IDEX? Okay, if you go to this option, you have this option to download for academic one free version. Okay, then go click this and it will download. But if you want more, I mean the features, you can choose the academic version or pro version. So it is around something around $1,000. Okay, but the same feature that they are providing here, even though it is not kind of user interface, we are not giving you user interface kind of thing, that is the graphical user interface, but the same feature that millions of molecule you can talk without any trouble using our script also. Okay, so essentially you are saving like this much if you need it. Okay, so in the laptop also you can do screening using our script. It won't crash, but the thing is, if you are docking like uh, some 100,000 molecule, then it will take time and you have to keep opening the laptop and keep running it for 10-20 days like that. Anyway, once you have downloaded this Pyrex software and install it, it's very simple installation. Okay, so no complex thing is there. So once you install it, you will get this shortcut. So once you open this, you'll see this interface kind of thing. So Pyrex also, you know, it gives you sometimes, I mean, problems. But again, if it gives you problem, uninstall it and install again and try from the beginning. Okay. So for free versions, for free tools, you have to be very patient. But the thing is, using Pyrex, using Vina, and using Autodoc 4 and using Autodoc tools, you can do real science. I mean, you can go for uh, virtual screening, then molecular docking, and even using these tools, they were able to get, drug molecules also. So this is not, something just to play around, but you can do also real science using these softwares. Okay, but before going for docking, we have only one molecule. So if you are looking for multi-ligand docking, let's download some molecules. Okay, let's create a library database. So we can use a Jing database for downloading the uh, molecules. Okay, so I'll provide you a tutorial for that, and this is the tutorial, the same thing I will provide you. So if you go through this link, again you have to be very patient with this web server also, because most of the uh, docking for this virtual screening, people are downloading from this server only. So most of the time we use a Jing database for virtual screening. So it got, servers, it's always get loaded, so it takes time to, load the data from this server. So be patient. So let's take this drug bank example. Okay, so this is a FDA approved drug molecules which are stored, or which are uh, kept in the drug bank database. Okay, so Jing database is a kind of aggregator, so it collects all the molecules or all the databases of small molecule from different sources, and they kept in their database. So they process the molecule and curate the molecule. Okay, so they have kept the hydrogen atoms, and they have changed it into 3D structure, they have minimized it, so it's kind of docking ready um, molecule in their database. Okay, so let's go for this approved one, that is approved drug molecules from a drug bank. Okay, so if you click here, so there are about 1491 molecules, unique molecule. Okay, and if you want to download these molecules, you have to, if you are using Windows, okay, you have to go for this. Let's do SDF files. Okay, so you have to go to Windows download, and you have to click here, SDF for Windows. Something like this will come, because they think that .bat file is some kind of uh, you know uh, virus or something, but it is not. So you can select here, keep, then go again, expand this and keep anyway. Okay, it's downloading. Let's go download it now. So I'm copying the downloaded file and again pasting this in the, okay, this will become confusing, so let me create one more folder. I'll call this as multi, or I'll say Pyrex multi docking, right? Paste it here. So what I'm trying to do is I'm trying to download the molecules, okay, from the drug bank database, which is hosted in the Jing database, right? Where's that? Yeah. So I cannot just directly click and download the whole this 1400 molecule. Okay. So if I try to download this, then maybe if the database is large, then it will, you know, uh, it will use up lots of memory, and maybe because when you transfer it will take long time, and also it can break the, if there is some kind of internet connection problem, it will break the whole download. Okay, so what they are doing is they are downloading this in the batch format, okay, batch file format. So for batch downloading, they have given you a script, this one, okay, usual sdf.bat, and if you open this in any text editor, you see this is downloading batch by batch. Okay, they are uh, compressing this file and then downloading in two batches. Okay, and here is the website or the web server address from where they are going to download, and we need a program called wget for this to download. So let's install this wget again. So if you open this tutorial, there is the link for downloading the wget program. Okay, so after this, after going to this address, you have to download the, if you are using Windows, you have to download this .exe file. Okay, most of your system nowadays will be 64-bit, right? So you have to download this option. It got downloaded, and from the download folder you have to copy this particular file and then paste it in the your working folder. Okay, let me just change this. I've downloaded 5 times, that's why it's coming bracket 5, right? And one more thing you have to change here. See, it's jink dot docking, but the thing is they have changed the database into 12, but they have not updated the address till now. So you have to keep 12 here, otherwise you won't be able to download. Okay, it will create it will show you an error. So you have to keep a 12 after jink, okay, in this web address, right? 12. So save this file again, and then now let's run this. So how to run this? You have to run through command prompt only. So you are in Pyrex multi-docking, right? But you are in Vina example. So where is Vina example? Vina example is here. So you have to come back one step, right? So for that you can do cd and then space dot dot. Okay, so you are out of this particular folder. Okay, so when you are out of this particular folder, you are in this Vina example before. Now you are outside of this Vina example, but still you are in this folder, but you are not inside this new folder that I've created, okay, for multi-docking. So if you want to get inside this new folder, then you have to type this cd space and the name of the folder you want to set your path to, okay, and press enter. Okay, if you do dir, you can see the files. So usuals dot, right, usual dot sdf.bat and wget.exe, right? Fine. So you just have to type this name of the file and it will automatically download. Press enter. So it started downloading. So this way, if you download batch by batch, so even if it is 1 million molecule, you can download very easily. Okay. Otherwise, if they are giving the whole file, whole molecule in one file, if something happens, it will crash and you have to start from the beginning. Okay. So this is how they provide a way to download. Okay. So you have to follow this if you want to create a database or library database from Zinc data. Okay, Zinc database. Fine. So you can just extract these files. So inside this folder, you have the SDF format of the file, right? So there are two files because they downloaded in two batches. And now, in order to avoid confusion, I just say FDA here, and let's copy from each of the files. I mean each of the folders, the files that we have downloaded, right? And keep it in this new folder named as FDA. But still, if you want to do multiple ligand docking, you have to combine these two, right? So how you can combine this? Again, you can go for this command line. Are you guys following? Are you with me, guys? Okay, good. All right. So we have to make a library of the drug bank FDA approved molecules, right? So these are in separate files now, but we have to combine this in order to do the docking for all of the molecules, right? So what we can do is you can again navigate to this particular path. So like multi-docking folder is here. Inside this folder you have FDA, so you have to go like CD and then type FDA. So you are now inside FDA now. So you can manipulate this now, the files, right? You have to keep this type, type, okay, and then give the name of the files. The first file I will do d dba00, then space, okay, dba p1.0, okay, and then keep a greater than sign, and this is telling that I want to combine these two files, concatenate these two files, and save it. Greater than means save this in a different file or new file. Let's keep the name of the new file as fda.sdf, right? So these two new files, I mean the downloaded files, will be concatenated and saved it in the new file name called fda.sdf. Okay, so when you press enter, you get this new file containing both the files. Okay, so you got the combined library of this FDA approved molecule. All right, so now let's come back to Pyrex. So this is the interface for Pyrex, and it's once you know how to do it, Pyrex is very easy. So if you want to do VINA docking, you have to select this one, this Vina wizard, and make sure that you select this Vina execution mode to local. Okay, go for this start option. Okay, let me just delete this. This is from the previous run. Okay, let me just delete this all. Fine. All right. So if you want to do Vina docking, you have to go to this Vina wizard option. Make sure that you selected the local execution mode, and then click the start. So here you have the option to add the macromolecule or the ligands. Okay. So you have, like in Autodoc Vina, you have to type in the ligand name, as well as if you are keeping the macromolecule in the configuration file, you have to keep the name of the configuration file, right? So here we can just add the name of the macromolecule. So how you can add is, you just have to click here. Since we have the processed receptor, right? So from the previous example, you can take the process receptor directly, and it will load it here. And if you are looking for single ligand, you can go from this option. Okay, but if you are doing multiple ligand, this option would not work. Okay, will not work. So for multiple ligand, we have just created a database, right? This FDA database. If you want to import all the ligand at one time and do the docking of all the ligand at one time, then what you can do is you have go to the file option, then you have to go to this import option, and then select this FDA format. Okay, and then click next. Navigate to the path where you have stored the library. So this is the one, right? FDA, and then this is the FDA molecule, right? Click open. So now it has opened a open Babel window. So it is using the same software, but it is giving you the interface to make it easy. Okay, so it is also using the open Babel to split the molecules, minimize or add hydrogen atoms if it is not there, or convert it into PDBQT format. Okay, but they are using the interface, user interface to do it. All right, so these are the molecules, but let's not do everything, all the molecules, because it will take time. So they already have added the hydrogen atoms, charges also they already there. You don't need to do anything for this. So but what you can do is you can convert this into PDBQT format. Okay, so in order to convert this into PDBQT format, you can just do a right click here. Okay, and then say convert all the molecules to PDBQT format. So when you click this one, it will convert all the molecules into PDBQT format. But let's not do that because it will take time. So let me just convert one by one. So you can, another option is to convert the molecule into PDBQT format for the selected molecule only. So let's go for this selected option, converted one molecule. So if you double click here, the converted one will be shown here in the ligand option. And again, let's do three molecules, right? So I'm selecting one by one, but you can go for this convert all option. When you are practicing, you can go for this convert all option. It may take half an hour or 1 hour depending on your laptop configuration. Okay, So now I have converted 1, 2, 3, 4 molecules, right? So now I can start docking. So here I am in the OpenBabel window, right? In this panel, OpenBabel panel. But for docking, I need to go to the Vina panel, okay, or the Vina wizard console, right? So you need to select the macromolecule. Already we have selected previously, so it will be in this particular folder. So when you select this processed ache.pdbqt, you see macromolecule, it got selected here. Okay, so one ligand is selected already because I just selected in the previous step. So if you want to dock all the four, then you have to press shift button in your keyboard and select all. Okay, so four ligands are selected now. So that's it. So you have to go to this forward button, and now you have this option to set the grid box. Okay, so what I find, you know, not that useful here is in the Pyrex, you can't just give directly the XYZ information, coordinates, grid information here. Okay, so manually you have to adjust like this. From here we cannot see where is the active site pocket. So what we can do is we can just import our uh, ligand so that we can uh, see where is the active site pocket, right? So if you look at here, still, because the xyz coordinate of the ligand is, we haven't changed anything, so this is the original ligand, so it will be inside the this ligand will be inside the active site pocket of the target molecule. So now we can adjust our grid box, and let's keep it in the middle of this, right, the molecule. So hopefully it's covering the whole active site pocket, right? So this is the only option I've seen, but if you know, you can also share with me. I have gone through their documents or manuals, but I'm not able to find the way to insert the XYZ coordinates manually like this. Okay, so once we are satisfied with the grid box that we have created, okay, then you can just go for this forward option. When you click the forward option, it started doing docking for the first molecule, and it will continue one after another, okay, automatically. So you don't need to provide the ligand name one by one, and you can the same thing that we have done in the command prompt, it is doing automatically here. Okay, it's done. That's it. So you can arrange this according to the highest binding affinity. So this particular zinc molecule is giving you minus 11.3, but the highest one was minus 12 something, right, for the drug molecule. So this is at the active site pocket, and I think this is our ligand. I think the poses are almost the same. So we can extract this and see in Mastro what is the interaction, and we can see if they are having the similar kind of interaction as the our experimental structure. Okay. So anyway, uh, you can download all this information using this option. So you can just click here and you will download the scores and the molecule name, okay, in CSV format. Let's say score.csv, and then for molecule you have to just select like this, and here you can type doc.sdf, right? But I don't think they will be downloading the whole structure. So it's only downloading the single molecule at a time. This one, right? Only one molecule at a time. All right, so we can just import this. Okay, it's not able to import the SDF file. No issue. We can convert this into, if you want to go back from command prompt, see this is in FDA where I've stored in Pyrex multi-docking, okay, outside of FDA, this one. So if you want to convert to SDF to some other format, you have to come back to the folder and then change O barbell and doc minus O doc dot mol2. Let's skip mol2 something. Okay, that's okay. Let's try to import this converted one. So this SDF format that you have converted from the Pyrex, it's having some problem to import, to be imported in the Mastro. Okay, so I have converted this to mol2 format. So let's see if I'm able to import this. Yeah, in the mol2 format it's able to import, and we can see how much different is that, and you can again import the receptor file. Okay, so this is how you can do docking. And you know, in case of Pyrex, even though it is giving you a nice interface for doing docking, but extracting the, let's imagine that this is like, you are docking like, this is only some 3 molecules, right? So if you imagine that you are doing docking for 10,000 molecules, okay, then it will be very difficult to manage, right? So for these conformers, like 7 conformers are there. So which one of this first conformer is having the highest score? So if I want to select only the molecules which is having the highest score, or the conformers which is having the highest score, and see the interaction in this fault means software or Maestro, it'll be difficult to take one by one, right? So if you want to take 100 or 50 top scoring molecule, it'll be it'll be difficult to manage like this. So tomorrow what we'll do is I will show you how you can do everything like this using the script. So in the script, you can download like this your library from the FDA molecule, I mean the from Zinc database, huge molecule. If it is not properly converted, but most of the time in Zinc database it is properly prepared for docking, so you don't have to worry much. But if it is, even though you are going to use, or most of the time people use from Zinc database, if it is from another database and it's not properly prepared, then you can do the whole preparation step using the script and then do the docking again. Okay, and then properly you can pick all the molecules, top scoring molecules, and store in a folder, and convert that also in the SDF format or Mol2 format, which is acceptable to this software. Okay, so after converting and extracting the top molecule, you just have to go here and then select all the molecules at one time, and then you can see what kind of interaction you have by just scrolling or just clicking the molecules. Okay, so that you can save time, and it will be convenient also, and it will be manageable for you for doing a large virtual uh, library screening using the script. Okay, so any doubt here? Yes, anyone? Okay, you practice. Okay, so I'm sure that when you practice, you'll face problems. So let me know if you're facing problem. Okay, all right, then we'll see tomorrow. So tomorrow we'll do the uh, scripting. Okay, Python scripting. So install Anaconda if you want to follow along with me, and then after that we'll go for that missing residues and all those, what are the important step that is required for choosing the right PDB structure, as well as if there are missing residues, or uh, if the structure is not available, how you can predict that. Maybe day after tomorrow for structure availability, but for missing residue we'll do tomorrow. All right, thank you so much. We'll meet up tomorrow again at the same time. Okay, bye bye.